Assalamualaikum and hi, my name is Kamal Aiman and we're from Group 4 and today we're going to present about high purity germanium HPGe detectors. Just a little bit of introduction of our group member. Firstly, we have me, Kamal. We also have Nurin, Najiha and also Hazika. So what is HPGe detectors? So HPGe or high purity germanium detectors are made by highly refining the element germanium and growing it into a crystal. So the crystal goes through a series of processing steps culminating in the attachment of positive and negative contacts which turn it into an electronic diode. The special property of this diode is that it conducts current in proportion to the energy of the photon depositing energy in it. So the relationship between energy and current is so precise in the HPGe detectors that energies are determined to be better than 1/10 of 1%. HPGe is the only radiation detection technology that provides sufficient information to accurately and reliably identify radionuclides from their passive gamma ray emissions. HPGe detectors have a 20 to 30 times improvement in resolution as compared of that, for example, sodium iodide detectors. Now, I'll pass to Nurin to talk about the results from our questionnaire.
We have done a questionnaire on public opinions regarding radiation detection technology. Based on the questionnaire done, we got a total of 28 respondents. From the 5 sets of questionnaire, I'm just gonna briefly explain the most significant outcomes for radiation detection technology. This is the result for how many people that actually know about radiation detector technology. Based on the bar graph, we can see that most people have average knowledge on such technology. Moving on to the next one, based on the pie chart, we get to know that majority of the respondents, which is 54.6% of them, know that semiconductor material can detect radiation. Next, we have listed multiple types of radiation detector and more than half of the respondents have selected HPGe as the best solution for gamma ray detection. Lastly, though half of the respondents are doubtful that the resolution of HPGe detector provides more reliable and accurate information to identify radionuclides compared to other detector technology, but 42.9% of them agree with this statement. To conclude, based on the questionnaire done, we can see that people are aware of the radiation detection technology. Next, Hazika will proceed to the working principle of HPGe detector.
Okay, so how does this HPGe detector works? For maximum efficiency, it works at a very low temperature, which is the liquid nitrogen is at negative 196 degrees. At room temperature, the thermal excitation will cause a very high noise inside the thermal detector. Next, we take a look at the model that we have built by using water plastic bottles. As we can see here, this is a collimator, the high purity germanium detector, germanium crystal, and also liquid nitrogen. Ionizing radiation enters and interacts with N-type germanium crystal within the depleted volume of the detector. So the high energy photon pass through the detector and ionize the atom of the semiconductor and produce electron holes pairs. Next, since the number of electron-hole pairs is proportional to the energy of the radiation to the semiconductor, the electrons will jump from the valence band to the conduction band as shown in the slide. Therefore, there will be an equal number of holes in the valence band. Last but not least, under reverse bias, the electric field will cause electrons and holes to move towards the electrodes. Then the deposited energy of the photons will be converted into a voltage pulse by an integral charge-sensitive preamplifier. By that, the energy of the incident radiation and also its intensity can be known.
Thank you, Hazika, for your explanation. Now I will explain the advantages of HPGe detectors. In comparison to silicon detectors, germanium is much more efficient for radiation detection because it has a higher atomic number compared to silicon. Not just that, germanium also has lower average energy necessary to create an electron-hole pair, which is 2.9 eV for germanium and 3.6 eV for silicon. Unlike silicon, germanium can have a depleted sensitive thickness of centimeters. Therefore, it can be used as a total absorption detector for gamma rays up to a few mega eV. If we compare HPGe detectors with sodium iodide detectors, HPGe detectors have 20 to 30 times better resolution than NAI detectors. Because of that, HPGe detectors provide sufficient information to accurately identify the radionuclides from their passive gamma ray emission. Unlike NAI detectors, HPGe detectors are resistant to information degradation caused by changes in background radiation, shielding multiple radionuclide interference and temperature variation. I think that's all for my part. I will pass back to Nurin to conclude our presentation. Thank you.
To put everything in a nutshell, due to its superior resolution, HPGe is the only radiation detection technology that provides sufficient information to accurately and reliably identify radionuclides from their passive gamma ray emissions. That will be all from us, thank you.